Yeah, hello everyone. Thank you for that warm welcome. My name is Stefan, and I want to talk about our approach of the IPFS the IPFS integration into the amazing Substrate system. So yeah, this is me. I'm from Germany. Second time here in Copenhagen. First time ever speaking at the conference. Yeah, and I'm working at a company called TDSoftware. I started my software engineering career back in 2005 as a C++ engineer, slowly transitioned into the mobile world, but always kept track on, let's say, code development through other projects in C++ and Go. And that was actually the reason my boss kind of approached me, I think in December 2022, and he was like, Stefan, I know you like software development the hard way, with all the manual memory management stuff and static linkages and whatsoever. Are you interested in learning Rust and do something with a system called Substrate? And I was like, why not? I mean, how hard can it be? I taught the Microsoft Foundation classes back in the days. So yeah, but I have to say it was quite challenging, but definitely it was worth the ride. Fall in love with Rust and Substrate, yeah. So IPFS and Substrate, what's the motivation from us behind that? So the company, TDSoftware, actually supported the development of a couple of blockchain-based products and technologies. One system one blockchain in particular is called DentNet. DentNet is, let's say, a blockchain for mobile network operators. Now, what does it mean? Imagine you get a phone call, or you're calling your boss, for example, saying like, hey, I heard a nice talk back in Copenhagen about IPFS, and Substrate should really try it out. And once you do that, your mobile provider actually kind of writes a lot of data, metadata, so basically things like the duration, the date, the time, and all of this kind of stuff. And this data is called core data record. These core data records are passed to the DentNet blockchain. We then basically compute the remaining and expired, voice or data packages out of it and write that on-chain. But we also kind of have to store this core data records. And actually, they can get quite large. So out of multiple reasons, we did not want to store that kind of stuff on-chain. So we needed to kind of find an alternative approach, but an approach that also sticks to the philosophy of Web3 and decentralization. So we did a lot of research and actually kind of came across IPFS, which means Interplanetary File System, to solve that mystery. And it's basically a peer-to-peer network protocol for distributed file storaging. Sounds simple, but behind the curtain there are like a lot of advanced algorithms for data distribution, data chunking, and whatsoever. So have a look on their white paper. It's really fascinating. But as a user, it's actually quite simple. Because if you put data into IPFS, you will receive a so-called content identifier that uniquely identifies your data. The CID is based on cryptographic hashing. And if you want to access your data, you can simply go to a public gateway, such as IPFS.io/IPFS, put your CID behind the URL, and then you receive your data. We like that. Simple, clean. So we thought, hey, let's use that. In our first idea, we were kind of like, let's build, for example, a CDR handler that takes the data, the CDRs actually, then perform the computation, put the data on-chain, then let's encrypt these CDRs, put them to IPFS, get the CID, and write this kind of stuff back on-chain. But this kind of thing is like a multi-step process and does not apply to the philosophy of Web3, because it's not decentralized if you have like a single point of entry. And so we thought, hey, we actually have the source code, and we kind of did a little bit already with Substrate, so why not integrating it directly into that node, into the system actually. And then we thought there might be actually other use cases. to where we kind of want to put data into IPFS. And finally, we came with the idea actually to make this kind of stuff public and contribute it to the community for you to use it as well. Yeah, that's. So basically, what we achieved was we integrated directly an IPFS node into Substrate. So once your Substrate node launches, it also launches an IPFS node to communicate with the whole IPFS network. So you can now perform these kind of operations in a single step within your palette or in your extrinsic or wherever you want it. We also added the IPFS APIs and also a couple of, let's say, low and high level pallets for you to make use of it. So yeah, this is basically the solution we came across. So yeah, there is like IPFS nodes, the IPFS APIs, and a couple of pallets. And yeah, so if you want to try that out, please check out the repository. There are no further, let's say, dependencies. You can just use it, compile it, launch it. That's it. Now, how to actually make use of it? So the easiest way to use all of the IPFS or the basic IPFS functionalities is through a palette called TDS IPFS. There we offer you extrinsics for adding bytes into IPFS, as well as RPC calls to actually receive gateway URLs of your stored data. So in general, feel free, check it out to, yeah, I don't know, include this palette, duplicate it, extend it, whatever you want. It's actually quite easy to add additional IPFS features if you want, because yeah, we're nice guys. We left a couple of documentation and also other examples there. So yeah, again, feel free to check it out, try it out. And if you find a couple of bugs, please report them as well. We're happy to fix those. All right, so yeah, kind of have a little demo prepared. Let's see how this works. So yeah, here is the famous palette interactor. Here's the IPFS palette. And yeah, with add bytes, you can actually put data into IPFS. Received bytes refers to the data you want to put into. Yeah, version I will explain later. And then there is also metadata that you can use also to identify your data you put into besides the CID. Okay, now it's running. And here we go. Now we also added kind of an example UI that refers to the extrinsics and the RPC calls. And here you can fetch the data from the gateway through the metadata. And as you can see in the browser URL, this is basically the public gateway. So yeah, quite simple, quite easy. Now let's dive a little bit in the details of the extrinsics. So as I mentioned, add bytes basically adds bytes to IPFS and will return you the referring CID. You have to pass 3 parameters: data, that's the data you want to put into, then a version that refers to the content identifier version. There are 2, version 0 and version 1. It is kind of, yeah, you should use actually version 1, but we also kept version 0, I don't know, out of legacy reasons. And then there's metadata, as I mentioned, and this data can also be used to identify the data apart from the CID. This data is not going to be added to IPFS, but will be written on-chain, so that means, yeah, keep it low. All right, now here's a little sketch on how it actually works. So imagine you have your Web3 client application or your palette or whatsoever, and you want to like pass data using the add bytes extrinsic. So what we're doing is we receive the data and the metadata, and the first thing we do is we put this data into the off-chain storage. Because, and that is important, IPFS APIs are only available within the off-chain context. So we put in the action, which is add bytes, data, metadata, and of course also the block number. And once the off-chain worker is called with the referring block number, we're going to query the off-chain storage and have a look on if there's data scheduled. And if so, we're going to take this data out, analyze the action, which is then add data, and perform the action with the IPFS node. And if everything works out quite well, we get a result, which is the CID, and then we go back to the on-chain context by invoking OCW callback. Then this is actually your opportunity to hook into it. So yeah, at that place you can basically perform your custom action. Kind of like in the CDR example, then we would kind of glue together this on-chain balance entries together with the CID. The default behavior is that it basically writes the CID and the metadata on-chain. All right, now we talked about how to get data into IPFS. Now actually how to access the data within IPFS. And therefore, we kind of created two remote procedure calls. One is called getFileURL for CID, which will return you the public gateway URL if you have used the add bytes extrinsic. And then there's kind of similar functionality for metadata. So if you kind of query it with metadata, we're going to have a look on-chain if there's an on-chain entry, and then return you the gateway URL for that as well. So basically, the request is similar for both. You have your params array, you add the either the CID or the metadata in, and then you either return then in the response an empty array if no entry was found. Otherwise, you will get the gateway URL. So this is like how the request looks like for CID. You have the params array, you put your CID in it, and if everything works out, you will receive this. You will receive this response here. And same for metadata, and you will receive basically the same response for that. All right, there are still some limitations. First of all, one thing you have to consider is the IPFS network latency. So if you put data in it, you cannot assume that it's available through the gateway right away. So sometimes it took seconds, sometimes it took minutes, also hours, so keep that in mind. Furthermore, I think you heard now extrinsic, and that kind of, I think, should ring some alarm bells, because using extrinsics actually limits the maximum size to the maximum block size. And this is like something we currently deal with. And therefore, as an outlook, we are actually currently working on trying to integrate streaming mechanisms into Substrate, like file upload systems. So, because I think there are like maybe a couple of more use cases actually where you can put bigger data to your pallet, then I don't know, make some calls with other web APIs, receive the result, and put this result on chain. Yeah, and we are looking forward for your feedback. So once more, please try it out. Here are the repository links. Also for the front-end template, we also kind of, as I said, made a front-end example UI that accesses the extrinsics and the RPC calls. And a colleague of mine actually wrote a nice Medium article where the implementation is, let's say, kind of explained in a little bit more detail. Yeah, and that's it for what I want to show. And if there are some questions, I'm happy to help.
Are there any questions? Yes, over there. Yes, the microphone is coming.
Hi.
Hi.
So I assume this is an opt-in kind of, like collators can opt in to actually run the IPFS software on the side, or is it just running for full nodes? It wasn't clear.
Sorry, I didn't answer the question right.
So I assume that the IPFS, let's say, binary runs side by side with the collator software, right?
Yes, exactly. Yeah.
So is it an opt-in for a collator to run the binary? Like, can they choose not to run the IPFS node? And
yeah, this is a feature we could actually add. Right now, it starts automatically, but I think we can opt in or opt out that. This is like a possibility to do. Yeah, should be easy actually. Yeah.
And
but, yeah.
Do they just kind of, when I decide to store something on IPFS, does the binary only kind of forwards the actual storing somewhere else, or it actually stores the file itself also on the server?
I mean, IPFS works in, I would not say mysterious ways, but it actually chunks the data and distributes it all across. So what the node is actually doing with it, I don't know. You kind of like pass the data in, and it does something with it. But you actually, what is possible is you can get the data out of your local node. So if you have put in data into the local node, you're also able to access only the running node and get the data out of it. That works for sure.
Yeah, I was assuming that the node would actually act as a gateway in that case.
Yeah,
right?
exactly.
So you could query it for the data. And just another question then, what's in it for a collator? Like, what is the kind of benefit they have if they actually store, like if they provide the IPFS feature? So they have to steer, it takes some storage space on the collator side. What is the incentive that they have to actually run this?
Yeah, I mean, yeah, first of all, like this blockchain already runs like for 1 year, and we already have like, without that, we already have like 100 gigabytes, I think. So quite a lot of data. That's why we actually wanted to source this kind of thing out. And again, as I said, the data is spread then all across the planet. So it makes sense to not, or like to, and what they actually also do IPFS, they also kind of take care of data redundancies and whatsoever. So we just wanted to, and we wanted to have the blockchain really like responsive and kind of try to reduce the amount of data that's into it, and that we could solve with IPFS actually. If that answers your question, hopefully.
It was rather like, okay, you said it's not opt-in right now, so it actually runs side by side with the collator software.
Yep.
But if, let's say, if we make it opt-in, why would a collator choose to run the IPFS binary compared to not? Like, what is the, do they get any economic incentive to actually, you know, I don't know, provide IPFS files?
Yeah, I mean, that's up to the use case, I would say. So, like, I don't know. If you wanted to store like bigger data, keep your blockchain, I don't know, responsive and like low, then just use that.
Maybe I can jump in here.
It's my boss actually, yeah. So
thanks, Stefan. Great presentation. So this is running the use cases in I heard the term now, an app chain, right? So on a solo chain. So that's where we have the control about the economics, right? So if you put it to the ecosystem, right, and the collator, that's I think the next stage, right? So we contributed this to the network now, and we are currently in the discussion how to integrate it more deeply, right? Exactly, yeah. That's why also this let's say, different types, we have it on the roadmap, but it's just not relevant now, right?
All right, thank you guys.
Okay, thank you. Thank you, Stefan.